I speak how to make bioethanol. This is sugarcane.
No, sugar cane.
And this is sugarcane. In Brazil, people make a lot of bioethanol from this sugar material. This is sugar corn. We can make bioethanol from this amyloid too. In America, people use 40% of corn production. We can make bioethanol from this construction waste. This is a recycling. Great. In this case, we press it first, and we ferment it. In this case, we break it and convert into sugar. After that, we heat it in 90 degrees, and we ferment. In this case, we break it and hydrolyze it by acid or enzyme, and we ferment. In such an instrument, we ferment it by fermentative bacteria. In Japan, people use okara for nutrition of bacteria. Okara makes from bean. At last, we distill ethanol and it became 95% ethanol. Furthermore, we dry it and we get 99.5% ethanol. Bioethanol is needed for cars now. Okay, my first finished. Let's move to next one.
Hello, in my part I will introduce you about microbial fuel cell. Microbial fuel cell is usually called MFC in short, and I found the definition from the Wikipedia. It says microbial fuel cell is a bioelectrical chemical system that derives an electric current by using bacteria and mimicking bacterial interaction found in nature. Next, I will show you a picture of construction of MFC. It is almost the same as a battery we learned during the high school, but the anode is quite different. Bacteria live in the anode and convert the substrate to carbon dioxide, water, and energy. After leaving anode, electrical travels through the circuit to the cathode. Electrons and protons combine at the cathode. Oxygen reduced to water. And now I think you have known the MFC. So let's talk some advantage of MFC. Firstly, the raw material is FFC. The raw material of MFC is bio-waste, so it can save money. Secondly, MFC can change energy to electricity directly.
Hello everyone, we are now talking about the bioenergy and biofuel. So maybe there's one type that is very well known and I think it exists in your country. It's called biogas, and this is our ingredient. It's a cow dump and pig dump with maybe leftover food, combine it up together. So this is the brief of the system. Like we have ingredient and we put it into one pot, and then it will pass through an amazing process called anaerobic digestion. Very hard to read it anyway. So the microorganism gonna use this kind of process to make the gas that's called methane, and which is very easy to be ignited. So it's useful to be energy. So usually the install system is gonna be like we intake the ingredient into one pot, and here we will have the active solid as a medium for cultivate the bacteria, and the bacteria will produce the methane and send it to every household. Also, you can use this liquid to be a fertilizer for your plant if you have farm. And also, not only the household is used this biogas, but also the industry level use it. You see, like this is quite big, and I bet this is a factory. Okay, so you can see that biogas have many kind of advantage, but also the biggest demerit of it is it produces methane, and the methane encourage global warming if you let it leak. Maybe it's quite normal, but prepare for the next one. It's amazing.
So today I would like to talk about the artificial chloroplast. So you can see this is chloroplast, this is artificial chloroplast. They both have same structure of this, and this is called grazes. And they not only just have same structure but also have same function, because they both can decompose the water to become oxygen and hydrogen. So according to recent study, this is MIT report, this is called artificial lift. They can use the light to simply decompose the water to become oxygen and hydrogen. So they will, I think they will become the new study in the bioenergy, because the scientists imagine we can put this on the car, and the car can use the sunlight to decompose the water, become oxygen and hydrogen, and they will use the hydrogen to drive the car. But so far humans still can control the power of hydrogen, so they still on the research. But you can see also the bottom side I write the semi-chloroplast. So because the chloroplast not only decompose the water but also can consume the carbon dioxide. So this, you can see the artificial chloroplast still do this part, but this part the artificial chloroplast didn't do it. And this is the carbon cycle. And it's like a bigger inspiration for me. So because it's a little far from the bioenergy, but I still want to talk about this, because if we really can do complete of the artificial chloroplast, we maybe can easily solve the problem of global warming. And so what we do now, so we just want to do this picture, because so far we don't know everything about this, and we still need a more student to study of this. So what we do now is we want you in the study.
So this is recent study according to MIA, and you can see this is called artificial life. They can simply deposit the water.
MIT.
MIT? Yeah.
Doesn't it? You say MIA?
MIA? Yes, yes. Okay, sorry.